Next generation higher power calculations formula and its implication. Now, in 2000, there was a good visual outcome was our surgical goal, and over the period of time, the next decade was the good effective outcome. And over the period of time, because of the invention like a very good optical biometry and the keratometry measurements, and the refinement in the surgical processes also and the equipments also, the excellent effective outcome is our goal. So, as Dr. Harshul has told us about the how precise optical biometry and how the very good excellent we are getting it, and all the other equipments where we are getting a very good precise keratometry, a total corneal power from the various machines we can get from anterior surface, posterior surface, and the calculation by the Gaussian optic or the ray tracing technology, and we are getting the very good total corneal power. So the source of error or the magnitude which was present before, where the excellent and keratometry reading has been gone much down, and the another remaining part is the effectiveness position is considering as a major source of error nowadays. And to get rid of that, so many versions formulas like a Gaussian optics formulas from the third generation formula like Ladas 1, SRKT, or for Q, which we are using the two variables, the increasing the over the period of time, the more and more variable, like he has introduced the anterior chamber depth, or the Barrett has introduced the lens thickness and the white to white measurement, and the Holaday has introduced the age factor and the pre-existing reflection part. So all these formulas increasing the variables to have a better and better calculation of effectiveness position. And this is the regularly we are using these slides in so many years. All these formula from third generation onwards, they are very good for the normal eyes, but when we are going for the short eyes or long eyes, they are not working very well. And the newer formulas, other than the versions formula like the ray tracing technology or the artificial intelligence, has definitely a more role in this kind of formulas. And another important thing is the anterior segment anatomy. When it is a normal, the older generation formulas are working very well, but when the anterior segment is not so good as compared to the other structure of the eye, then we need other formulas like this. So nowadays the predictors has been changed over the period of time, and so many other formulas are coming up, and they all are using the more and more predictors or the predictors. Like majority of them are using the axial length, keratometry, and anti-chamber depth. But the lens thickness is now, all the newer formulas are coming up with increasing in the consideration of the lens thickness. And further, people are now also considering the corneal sphericity part and the corneal posterior-anterior ratio. So many formulas are there in the 2021. Besides the third generation formula of Upper Q, Holaday, and Higgins and SRKT, we have a middle of the decade was this Barrett Universal and Olson. The newer formulas from 2019 onwards, we have RBF, EVO, Kane formulas, Panacea, Paul DGS, T2 formulas. All these formulas are coming, and we are very much confused which formula to use and when to use which formula. And all these are easily accessible, free of charge on these different websites. Very few are chargeable. So accessibility is also there, which was a question before. So now, which formula to be considered? At present, in 2021, all over the globe, across the globe, the 5 top formulas are the Barrett Universal 2, Kane formula, EVO formula, RBF Calculator, and Olson's are commonly used at present. But most important part over these is, without regular optimization of their performance, no one is superior than the traditional formulas. So you have to constantly go on optimization your results. Now we go each and every detail of these individual formulas, like Barrett suite. Barrett suite is consists of the 3 components. One is the Barrett Universal 2, Barrett TORIC, and post-refractive surgery IOL Barrett 2K. This is incorporated with the IOL Master 700. And it is a new generation formula, which is a theoretical model formula. It also considers the anterior chamber depth, axial, and then keratometry in the consideration. And the most important part is a thick lens formula. So whatever the IOL model, whether you are using a regular model of the biconvex, and if you are using for the high meniscus lenses like in high myopia, it gives a different lens construct. So the same way, the Barrett TORIC formulas is also taking in account of the posterior surface of the cornea And now he has incorporated both the things, actual measurement of PCA and also the based on the nomogram. Now this is the way Barrett gives the results in our IOL Master 700, and there are two constant. We have to understand these two constant. That's why I have kept this slide. Now Barrett has two constant. One is the LF value and one is the DF value. LF value is the Barrett formula IOL constant, like what the SRK TA constant which we are using it. But DF is a constant which is when the lens is transit from the biconvex to meniscus lens, which I had told you before. And majority of the equipment where the Barrett is incorporated with it, it has a default value. But when you are using a Barrett formula or when you are using the lenses which are not, you are using the equipment where the Barrett is not incorporated, and if you are using the meniscus lenses, then you have to go for this DF value manually. So you don't go for the error for this. So Barrett is easily available on the APCRS website. It has 5 more features. Barrett 2K formula, which is meant for the post-refractive surgery IOL power calculation. Barrett TORIC calculator is also there. Barrett universal 2 formula for the conventional cataract surgery. Barrett treatment formula is meant for the post-cataract surgery refractive surfaces management. And Barrett 2K TORIC calculator, which is specifically meant when the patient has undergone the refractive surgery and you are planning to put a TORIC IOL in such patients. Now another calculator, the formula is the Hill RBF calculator. Version 2 is a very widely now used. It has artificial intelligence machine learning process. Here the Dr. Hill has done this data interpolation and pattern recognition by artificial intelligence of a few patients who have been undergone the cataract surgery with alcohol lenses with lens star measurement. But over the period of time, for the widening of the scope of this formula, more and more data he has gathered. And now his data set has been incorporating the high to extreme high myopia and high hypermetropia. This has been incorporated. So now Hill RBF 20 version is better for the extremes of the eye, and you should use the Hill RBF 20. Hill RBF 30, they are recently introduced one paper in the last JCRS, but we are still waiting about the newer version of Hill RBF 30. And this is the way the presentation comes on the screen when you are putting it. But now they here, rather than only the lens star, he has incorporated the further devices which you are taking optical biometry. Only the optical biometry Hill RBF calculator works. So for that you have to keep this in mind. Another formula is the Ladas Super Formula. The Ladas Super Formula, artificial intelligence. It has a very important part is the evolving formula. All the formulas which we are at present is the Vergen's formula or the ray tracing formula. There is a fixed equation. This equation, you put the data of the axial length or keratometry or the optical biometry or the axial length. Then they will give you output of your IOL power. So you cannot change it by your self or your results. While artificial intelligence is a data set limited, where the RBF or Clarke formula, where already the data set has already fed up and they had made artificial intelligence to work it up. But the LSF means the Ladas Super Formula, which is a formula which is evolving in such a way that whatever the dynamic system automatically adjusts by the formula. So data all over from the world which is in real time and it has been upgraded by itself. So this is the future of the IOL power calculations, that immediately you can go for the updated for your results. And this is the way it is available online, and it gives a presentation on the graphic report. And this is very easy and convenient to understand it also. Another one thing is Ladas Super Formula has introduced a newer version of 1.0b, and that includes the device refractive index factor. So device refractive index factor is a factor where the different devices are measuring the refractive index differently. And that has been incorporated now by this formula. So any inter-instrument variability of the corneal index has been put off. Now another important part in the Ladas Super Formula is the upgradation of the optical biometers by self-calibration. So whatever the results by putting your input data and the deep learning IOL calculation, you are getting the power result. And once you select the lens, do the implantation, and the water for the wavefront analyzer, that data has to be submitted into optical biometry. So the results, now the newer optical biometers are coming up in such a way that the Ladas Super Formula will keep updating by itself for the upgradation. The another one is a Panacea one. Panacea is a system, one of the calculator. But what is the only calculator of the TORIC and IOL power calculation? It has so many other features. So actually, everybody should download it on your desktop screen. So it will help you in your OPD for the refractive surgery or keratoconus and everything. As usual, the other biometric data he is taking like optical biometry, axial length, chamber depth, lens thickness. He is considering the age factor. But another important part is the topographic data. He is taking care of the sphericity of the cornea and the posterior anterior ratio of the cornea. That has been taken care by this Panacea calculator. And also it gives the presentation in different IOLs. What will be the present biphasic curve for the distant, intermediate, near vision for every individual lens? Suppose it's a bifocal or a trifocal or extended IOL, all the commonly available lenses all over the world. According to the patient's requirement of the distance dominance or near dominance, you can select it from this formula. Another good feature for Panacea calculator is it is considering a capsular back tilt factor. So in our next lecture, we are coming up that how the capsular back tilt factor has to be considered in the TORIC calculator. And this is the first TORIC calculator which has incorporated the capsular back tilt factor. Now the ray tracing technology for the IOL power calculation formula commonly used are the Oculix and the Olsen formulas. All our third generation formulas are the thin lens based formulas where the cornea considered as a single plane, IOL has been considered a single plane, and we are finding the effective lens position. At that time, the lack of the supercomputers, we were not able to find out every part of the cornea for the reflection point of view. So now, because of our better understanding and newer equipments, all the small map data, elevation database can be incorporated, imported to the Pentacam data has been incorporated to the Zinex ray tracing software. This is a software which has an optical engineering software. It's designed in such a way that it works in such a way that all the rays which are passing through the cornea and pupil and gives the point spread function, it retrospectively gives us the exact corneal power. What is the corneal power of even whether it is a normal cornea or abnormal cornea? So they perform better for the effective lens position calculation than the other thin lens based formulas. They are purely based on the optics, so they account well in the regular, irregular corneas. Even they consider the corneal sphericity. They also consider the IOL parameters, whether the anterior curvature and the posterior curvature of the IOL and the spherical aberrations of the IOL has been also taken care by the ray tracing technology. So this is a feature where you can customize your lens according to the requirement. And it is very useful in the complex cornea where the versions formula, all versions formula are not giving the proper K reading and you are getting the error in his effective lens position. So Olsen come with another one concept is the C constant phenomena. C constant, which has a new concept for the ray tracing assisted intraocular lens power calculation, where the C constant depends on the crystallized lens anatomy, where your IOL will be sit, where the middle plane of the IOL will be sit in your capsular bag postoperatively, and that is the retrospectively studied and the C constant has been immersed out. Another good formula which is coming up and widely used, not in our India but widely used now, is the EMETROPIA verifying optical formula. It is based on the theory of the emetropiation and generation of the emetropia factor in each eye. And this is also a very good part, is that it is a thick lens formula. So this is the EVO formula calculator. Now they are incorporated with the newer biometers like Argos biometer. They are also considering the lens thickness or central corneal thickness is also considered in the calculations, and they are taking the total 2K power, total corneal power in calculations. Very good part in this EVO is the TORIC formula. This is the only TORIC formula which has a very thick lens modeling formula for the different types of the TORIC lenses. And this is a theoretical posterior corneal estimation prediction. So it is not a measured one, it has a theoretical PCA predictions. And there is another important part is the dynamically interconnected prediction of the IOL power and toricity by the anterior toric, bitoric lenses or the posterior toric lenses. So this formula gives the option of which kind of toric lenses you are incorporating. So that gives us a more precise reading about the toric power calculations. Now the Kane formula, now everybody, all international forum, the Kane formula is now giving the same weightage as the Barrett formulas. It is also based, is a thick lens based formula. But another part is not only the theoretical optics, it incorporates both the regressions and the artificial intelligence component both. And one variable which is commonly used in the Kane formula is the gender variable, which is not there with any other formulae. And now please consider that it gives the accuracy extremes of the axial length. This is the Kane formula screenshot, and you have to feed up all this data. Now, another formula is the all-VGS calculator. This calculator, these three gentlemen has introduced this calculator. It is also based on artificial intelligence and optic based. But the very good part of this calculator is it can adjust its prediction using the post-operative data of the contralateral eye if it is available. So any refractive surprise or whatever the fallacies which when you received in the first eye, that can be corrected by this calculator in the other eye. And it also works very well now. The few more data are coming up that it works very well in the corneal refractive surgery patients. T2 formula, it is a newer version of the SRKT formula. It is nearly 10% improvement in prediction accuracy. It is available freely, and you can download it by. It can be downloaded by version 1.3 freely on the desktop. So this is the way I downloaded on my desktop to use the T2 formula. For the normal light, it gives a little bit better results than the used. Now you have so many new formulas: Barrett, Kane formula, Hill RBF formula, EVO formula, ray tracing formulas. Now, how to incorporate these in so many formula in the practice? Now, whenever you have a patients of the other than the normal range, like a high hyperopia or high myopia, put this calculate in all these formulas and compare the results. That will give you a how to do further work. Suppose this is a high myopic patient where the axial length is 24.99. All these newer generation formulas are giving nearly equal results. But this is the another case where the high hyperopic patients, where the results are variable. The Barrett gives the 30.5 while the Hill RBF gives the 29.50. Now, how to overcome this part also? Let's discuss. This is the case where the axial length is 27.48. Now, when we go for the calculations, the Barrett and SRKT gives it gives the 11.5 reading, nearly for all the patients. When you consider the EMETROPIA, it gives the range between the minus 0.22 to plus 0.25. But when you go for the 12 diopter power, it goes for the minus 0.54 to minus 0.07. So when I had opted for the 12 power, then it's gone near to the plano. So it's better to go for the little bit myopic side by the comparison of the different formulas. This is another example of the extreme myopia, where the axial length is 34.61. And when you go for the direct universal formula or the Hill formula or Kane formula, they works very well and they are giving the minus 4 power with nearly minus 0.34 to minus 0.78. But when you go for the third generation formulas, it gives a very erroneous results. But when, as a considering the long eye, when you go for the von Pohl adjustment, with the first constant adjustment from the latest ULIP data, the newer ULIP for the high myopia, and that gives the nearly same results, even for the third generation formulas. I think this extreme high myopia will be taken care by the Dr. Sonu. Thanks for your attention.